Now that we've seen some data that we would like to import into Elasticsearch, let's talk about mappings, which tells Elasticsearch how to store that information. So you can think about a mapping in Elasticsearch as a schema definition. It's telling Elasticsearch what format to store your data in and how to index it, how to analyze it. Elasticsearch usually has reasonable defaults and will infer from the nature of your data the right thing to do more often than not. It can figure out if you're trying to store strings or floating point numbers or integers or whatnot, but sometimes you need to give it a little bit of a hint. So here's an example of where we're going to import some MovieLens data, and we want the release date to be explicitly interpreted as a date type field. So here's what a JSON request would look like to do that. Now we're going to be using the curl command throughout this course. That's just a simple Linux command that allows you to send an HTTP request to the server that's running Elasticsearch. In that case, that's going to be our local host running within our virtual machine. And the syntax of the curl command is you need to specify the content headers using the -h command. So we're going to send along as part of this HTTP request a header that says content type application JSON, which tells the server that we're sending JSON formatted data. This is new in Elasticsearch 6. In Elasticsearch 5 and earlier, you did not have to send that header explicitly, but in Elasticsearch 6 you do. And it's going to get a little bit tedious, and in the next lecture I'll show you a way around that. Finally, we send in xput, which is the verb for the HTTP request, the HTTP action. We're going to do a put command to put information into our index. The actual address that we're talking to is 127.0.0.1, which is the loopback address for the local host. :9200 indicates that we're running on port 9200. And then we say /movies, which is the name of the index that we're manipulating. After that, in curl, we say -d and then a single quote that says that we're going to send along the following data as the request body. And those single quotes will enclose the JSON data that's actually the body of this message that we're sending into Elasticsearch. So that JSON body contains a mapping section, which specifies for the movie data type the properties of the following fields. Specifically that the year should be of type date. So that year type date is what's telling Elasticsearch that I want you to explicitly interpret the year field when it comes in as a date type and not just a string full of numbers and dashes. Mappings can do a lot more than that, though. So there are several things you might use mappings for. One would be for the types of fields like we saw previously, and some of the valid field types that you might assign to a field might be text or keyword. Those are subtly different. A text field is a string field that's actually analyzed and indexed for full text search, while a keyword field is not broken up into its components. So you won't get back partial matches on a keyword field, but you will get back partial matches on a text field if you're doing a search for part of that string. There's also byte types, short, integer, long, float, double, boolean, and date, all the usual different types for various types of numbers, and also dates are treated specially too. You can also control whether or not a field is indexed, and that's either true or false in Elasticsearch 6. So if that's true, that means the field is queryable, and it will appear within the inverted index for this index, therefore you can search for that thing. But if you just want to get it back as sort of data that comes along with other queries, you can set that to false instead and save some resources on your index. You can also control the analyzing behavior through mappings. So for fields that are indexed for full text search, if it's a text field, you might want to specify exactly how that text is broken up for full text search. And there are various specific rules for different languages. For example, English might have unique rules for things like stemming, so words that end with ing or ed might really have the same base to them, for example, and plurals are dealt with in a certain way, and synonyms are dealt with in a certain way. You can also have standard filters, filters that just break things up based on white space, whatever you want to do, but the analyzer mapping is how you control that behavior. So let's talk more about analyzers. There are three things an analyzer can do. One is character filters, so an analyzer can remove HTML encoding and do things like convert ampersands to the word and. So the idea here is that if you apply the same analyzer to both your search query and the information that's indexed, you can get rid of all these discrepancies. So if I apply this same analyzer that maps ampersands to the word and on my search query and in the data that I'm indexing, that means it doesn't matter if I'm searching for ampersand or and, I'll still get ampersand and results back from my inverted index. Tokenizers, that actually splits your strings up on certain ways. So how do I know what makes up a word? How are search terms broken up? The choice for your tokenizer determines that. You can, for example, split strings up just based on white space, on punctuation, on anything that's not a letter, and there's also language-specific ways of doing tokenization as well. So that's how you specify how a string gets broken up into search terms that get indexed. You can also do token filtering. And again, if you want your searches to be case insensitive, which usually you do, you might want your token filter to lowercase everything. So again, if you apply the same analyzer and the same token filter to your search queries and what's indexed, you can get rid of any case sensitivity if they're both lowercasing both what you're searching for and what you stored for things to search for. It can also handle stemming. So for example, if you want the word box and boxes and boxing and boxed to all match for a search for the term box, you could use stemming to normalize all those different variants of the given word to the same root stem, okay? Synonyms, also a language-specific thing. You know, if you wanted to search for the word big to also turn up documents that contain the word large, your token filter could normalize all those to a given synonym in order to make sure that those also work as well. You can also specify stop words. So if you don't want to waste space storing things like the and a and little words like that that really don't convey a lot of information, you might want to apply a stop word filter as well to your searches so you don't end up indexing all of that stuff too. Now, there are reasons to actually not use stop words, particularly for phrase search. So imagine back to our first example that we did back in lecture 1 when we searched for to be or not to be. All of those might be stop words, so they're all very common words. And if I weren't actually indexing those, then that search wouldn't have worked at all. So don't enable stop words lightly. Sometimes it has side effects that you don't really want. For analyzers themselves, there are several choices. The standard analyzer is the one you get by default. It splits everything by word boundaries, removes any punctuation, and lowercases everything. So if you don't know what the language is, that's a good choice to stick with. And that's what we are going to stick with for our movie titles, because we do have some foreign films in there as well. So in our case, for MovieLens data, standards is actually a good choice. There's also a simple analyzer that just splits on anything that's not a letter and lowercases everything and nothing more. And an even simpler white space analyzer that just splits on any white space that does not lowercase. So any punctuation will be preserved, for example, which you may or may not want depending on the type of data you have. Sometimes punctuation is important. There's also language-specific analyzers, so you can specify your text is in English or any other common language that Elasticsearch supports, which is pretty much all of them. And that can do language-specific things like handle stop words and stemming and synonyms, which is pretty cool. So if you do know that you're dealing with full text data that you want to do full text searches on and you know what language it's in, you can use language analyzers to do that. And sometimes you can even mix and match different languages in the same index. There are some tricks you can do to actually run different analyzers on the same text and store those as different fields. So I could have, for example, an English version and a French version of the information in my index that I could search separately. So with that, let's dive in and actually create a real mapping for some movies data hands-on. So let's actually set up a mapping for movies data in our Elasticsearch server. And I'm going to walk you through getting started here just this once. So again, to get up and running, start by launching the Oracle VM VirtualBox, assuming that you are working within a virtual machine and not on a real Ubuntu server. Select your Ubuntu Elasticsearch virtual machine and start it. And give that about a minute to spin up as it boots up. Nice thing is that it boots up pretty quickly, all in all, because we did install a bunch of extra software that we don't need. So we'll just wait for that to finish. And once we have our login prompt, we're not going to log into the console because, again, that's not how you would do it in the real world. Instead, we're going to open up our terminal application. So on Mac OS, that would be terminal. On Windows, it would be PuTTY. And again, if you want to connect for the first time, you would type in 127.0.0.1 for the host name here. Or if you already saved a session, you can just load that up to bring that right up. 127.0.0.1, port 22 is what it should say here. SSH should be selected and hit open. And we can go ahead and blow that up and log in using your own username and password. All right, so let's just make sure, first of all, that Elasticsearch is running. We can type in curl 127.0.0.1:9200 and just make sure we get something back. Sure enough, we do. So Elasticsearch is up and running and waiting for us to do something with it. So now that we're in, let's use the curl command to send a request to the Elasticsearch service that's running to set up that explicit mapping for the year field in our MovieLens data. So to do that, follow along with me here. We're going to use the curl command that sends an HTTP request to our server. We need to say -h to send the content type header. So -h, quote, content dash type. Pay attention to dashes and capitalization, it all matters. Colon, application, /JSON, end quote. And then we need to say -x put, because we're sending a put command to our server. That's the HTTP action. The service that we're going to talk to is 127.0.0.1. That's our localhost's IP address, :9200, because Elasticsearch operates on port 9200, /movies. That's going to tell Elasticsearch that we're working with the movies index. And then we will say -d and then a single quote. And that just tells curl that the following lines are going to be sent as the body of the HTTP request. And that body should be, as we indicated, JSON data. So because it's JSON format data, we will start with a curly bracket and hit enter. Now I'm going to make pretty tabs here to format our JSON data nicely. You don't have to do this. Tabs are optional, but if you do want to type a tab character, there's a trick to it. You need to say Control-V and then tab. And that's how you actually enter a tab here. So we'll say, quote, mappings, quote, colon, open curly bracket, another tab, quote, movie, because we're dealing with the movie type, colon, curly bracket, tab, 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 and then we were going to define properties within that type, properties, in quotes, colon, curly bracket, tab, 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 tab. And in the year field, we're going to say colon, curly bracket, quote, type, colon, date. All right, so I'm kind of compressing all this into one line because I'm getting tired of typing tabs, but it all works the same way. And finally, we need to close off all of those curly brackets. There's 1, there's 2, there's 3, and the final one, 4. And we'll close off this request body with another single quote. Double check everything, make sure it looks right. So again, to review, we are using curl to send an HTTP request with a content type header that indicates JSON data, a put action to our local host on port 9200, affecting the movies index, and we're defining an explicit mapping for the movie type that changes the property of the year to be interpreted as a date type. Let's go ahead and hit enter and see if it works. All right, you should be seeing something that says acknowledge true, shards acknowledge true, index movie. So it looks like it worked. Now, if you want to retrieve that and make sure that it actually took, we can use a get action to get that mapping back and take a look at it. So let's say curl -h, quote, content -type, colon, application -json. Typing that header in all the time gets tedious. So in the next lecture, I'll show you a way around that. This time we're going to do -x get, because we're doing a get command to get information back from our server. 127.0.0.1 is our local host address. Port 9200 /movies / mapping to retrieve the mapping associated with that index specifically for the movie type. So that's what we're saying here with this syntax here. Let's go ahead and hit enter and see what comes back. That's interesting. So we got back a JSON blob, but it's not very nicely formatted, so it's kind of tough to read. Let me show you a little bit of trick there. I'm going to hit the up arrow to just repeat my previous command, but at the end, I'm going to type in a question mark pretty, and that will cause the response to come back in a pretty formatted response. Let's take a look at what that looks like. That's a little bit easier to read, isn't it? Much closer to what we typed in, and you can see that our custom mapping did get stored in this index successfully, so cool. We have now told Elasticsearch that when it sees a year field in our movies index under a movie type, that should be interpreted as a date and not as a string. All right, so next we need to put some data into this thing, and well, first I'm going to show you that hack about avoiding that -h command. If you're done for now, however, you can just type in exit, and that will get you out of the SSH shell. And if you want to shut down, you can say machine ACPI shutdown in VirtualBox. And at that point, you can safely close down the VirtualBox manager itself. Okay. All right, let's move on.